Hello, this is Mohammad Yasir Arafat, and today we are going to discuss last topic of our chapter number 3, that is dynamics. And the name of the last topic is uniform circular motion. So we must know how we can produce uniform circular motion. For that, we need to remember Newton's third law of motion, where it has said that every action has an equal but opposite reaction. That means the forces applied on an object must remain balanced. And remember one thing, when the forces applied on an object remains balanced, by that case, that object will be at the state of rest or moving with uniform motion. When we are discussing uniform circular motion, we need to remember that we must study a change in position or the change in equal position in every time interval in a circular track. There are two examples are shown here when the earth is moving around the sun and the revolution of electron around the nucleus. So remember one thing, the earth is revolving around the sun with a uniform circular motion on a circular track, and same happens with the electron that is moving around the nucleus. Here, the change in position on a circular track will be equal. The change in position on a circular track is called circular motion. Remember one more thing, that how uniform motion can be obtained. So to obtain a uniform circular motion, we must keep the force applied by the earth and the force applied by the sun. Here you can see the example. For example, this is the sun and this is the earth, and this earth will be moving around the sun on this circular track. Here, the earth will be applying some amount of force due to its gravitational force on the surface of earth to attract it towards its center, and in the similar way, the sun will be also be applying the same amount of force to attract the earth towards itself. Here, both of the objects are not moving to each other due to the balance forces. That means their magnitudes are same, but they are acting on opposite direction. When it happens, इनके जो मैग्नीट्यूड ऑफ फोर्सेस के सेम होने की वजह से क्या होगा कि फोर्सेस बैलेंस होंगे, एंड फोर्सेस जब बैलेंस होंगे तब ये ऑब्जेक्ट जो है यानी अर्थ जो है वो सन के अराउंड रिवॉल्व करेगा. एंड इसके लिए हमें हमारे पास कॉन्सेप्ट होना ज़रूरी है फॉर द सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्स. फर्स्ट वी मस्ट नो कि यहाँ पर सेंट्रीपिटल फोर्स क्या है और सेंट्रीफ्यूगल फोर्स क्या है. फोर्स अप्लाइड बाय द अर्थ कैन बी नेम्ड एज सेंट्रीपिटल फोर्स. यानी जो फोर्स अप्लाई हो रहा है फ्रॉम द सरफेस ऑफ अर्थ ड्यू टू द इट्स ग्रेविटेशनल फील्ड, दैट force can be named as centripetal force. And the force applied by the sun, that is at the center of the circle, and that force will be named as centrifugal force. So centripetal force usually directed toward the center of the circle, and that force will be named as centripetal force. Just like same example agar hum use करें, so this force can also be named as centripetal force. और ये फोर्स कैलकुलेट करने के लिए वी कैन यूज मास इनटू स्पीड, स्क्वायर ऑफ स्पीड और वेलोसिटी डिवाइडेड बाय आर. अब स्पीड मास क्या होगा, मास वो मूविंग ऑब्जेक्ट, जो भी मूविंग ऑब्जेक्ट है, वेदर इट कुड बी अर्थ और इट कुड बी इलेक्ट्रॉन, और ये मूव करे अराउंड द सम ऑब्जेक्ट, जैसे कि ये मूव कर सकता है अराउंड द न्यूक्लियस, इट कैन बी मूव अराउंड द सन एज वेल. सो जो मूविंग ऑब्जेक्ट है उसका मास m से रिप्रेजेंट करेंगे, एंड मूविंग ऑब्जेक्ट की जो स्पीड या वेलोसिटी है दैट वुड बी नेम्ड एज v. एंड वी ऑल नो दैट ये सर्कुलर ट्रैक में मूव करेगा, दैट इज व्हाई हम यहाँ पर यूज़ करेंगे रेडियस एज वेल because we all know that the distance from the center of the circle to any point on the circle that would be named as radius. Now here the centripetal acceleration required to revolve in the circular track, that is called centripetal acceleration, and centripetal acceleration can be calculated by using A is equal to V square divided by R. Thank you for watching me. Let's wait for the past pair solution.